All right, so what's up, kids? We're going to be learning about the arc length today. And the important thing to notice here is the difference between an arc length and an arc measure. The arc length is an actual distance. You're going to get a number, and Siegel's going to mark right there. That's the length. Now that's different than the arc measure. A measure, in this case, is you see that X with a degree? That's going to be your measure right there. So that's when you see 120 degrees. That's not what we're working with today. We're actually going to be getting an actual number that's going to represent a distance 10 feet. Now our fraction, or excuse me, not our fraction, our formula for arc length is the measure of our arc, so that number is going to come in handy, divided by 360 times 2 pi r.
What's this formula remind us of?
2 pi r reminds us of, what is that, circumference? Is that what that is?
I think so.
The circumference of a circle. So as you can see up there, it says the fraction of a circumference. Well, that's where that comes into play. But this is your formula that's going to get you through this whole section. So copy it down, make sure you have it, and we're moving on. All right, now let's see some example problems. Find each arc length. The steps up there are given to you, right, the formula. So let's start there with step 1. The formula for arc length is same thing as before, the measure of our arc over 360 times 2 pi r. And now all we have to do here is find the pieces that we're missing, right? So let's find the measure of our arc. Now right there, we see it. Now remember, when you're looking at the measure of an arc, that's the degrees, so it's going to be 50 degrees right there, perfect, since it's a central angle. And then our radius is given to us as 5 centimeters. So now we have all the pieces we need to solve this problem. So the length is going to equal that measure of the arc, which in this case is 50 degrees, over 360 times 2 pi and then 5, which is our radius. And so we go through, we do the simplification of that, and you're going to get, 50 over 360. Hold on just a second, kids. And so now on your calculator, we should break this down into pieces. So we'll show you how to do this. So 50 divided by 360. I'm going to write this first number that I get, which is, we'll just round it to 0.14. And then we want to times that by 10 times 3.14. If you want to know where I'm getting the 10 from, I just did the 5 times the 2. And then for pi, we've been using 3.14, so it's just the easier way to make the calculation. So we get 31.4. And so now we just times that by our original number of 0.14, and we get our final answer of 4.396. And they would tell you how to round it. We're just going to leave it like that. But it's really important when you're working on the calculators to break it up into pieces like that. I think a lot of you try to put it all in at once, and it gets you in trouble. And that's your arc length. So if you were to actually measure from A to B, you would get that as your length. All right? So now let's see what we got here. This is problem number 4. So length of EF. Now this problem set up the exact same way, but we're going to show you another example. So we write our formula first. So it's the measure of the arc over 360 times 2 pi r. The measure of our arc, as you can see in there, is 100 degrees. Remember that works straight across because it's our central angle again. And your radius there is 7. Now we just plug everything in. So the length equals the measure of our arc, which in this case is a hundo. Divide that by 360. And times that by 2 pi and the radius of 7. And so same thing, we're going to break it into pieces. So we have 100 divided by 360 is going to give you that huge number, which we're just going to round to 0.28. We'll round to the nearest hundredths. And then we've got 14 pi, which when you do the calculation on this, we'll times it by 3.14. Which once again I get 14 because I did 2 times 7. I get 43.96. And now just to finish it off, I times that by 0.28. And I get my final answer of 12.30 0.088, which if you were to round to the nearest hundredth would be 12.31. They'll specify when you do a problem, but that's your arc length right there. What do you think, Steve? We think they're pretty good? I think we have a couple more problems. You guys will be all right. Here's the next one. So this is working the other way. And with this, you're going to be writing down your formula, but you see now they're asking you to find the measure of that arc. But let's see what we have so far. The length is the formula, measure of the arc, over 360 times 2 pi r. All right, now what did they give us?
So what are we trying to do in this one?
So in this one, it's saying that you're trying to find the central angle, the measure of the central angle, which in this case is that right there, but we know that's the same as our measure of the arc. Exactly, great job. So what did they give us? They gave us the length. The length is 15 pi. And so we know the length is 15 pi, and the measure of the arc is what we're looking for, so we can call that x, over 360 times 2 pi, and in this case our radius is 18. Now something nice can happen here that Siegel pointed out to me before. You see how there's a pi on each side? We can cancel those right out. So those pi's are gone, which makes the math a lot easier. And now we see that division by 360. We're definitely going to try to move that over. So Siegel's going to take the pi's out for you. And then 8 times 2 we know is 36. And actually we can do something a little smoother right there. What do you think? Should we move 360 or should we cancel something out on the right side there, Siegel?
I think we should just divide it, or
Does it matter? It probably doesn't matter, right? So we'll show you one way. If you're curious about the other one, ask us. We're going to get rid of that division sign by moving the 360 from the right side to the left. Now you know in order to get rid of division, we have to multiply to the opposite. So we're going to multiply both sides by 360. When we do that, the 360 is going to very neatly go away on the right side. It's going to cancel out. You see how that's gone? And so now what we have to do is clear up the left side, which is 360 times that by 15, and you're going to get 5,400. And that's equal to 36x. And now this is way back to Algebra 1, and probably before that too. Very simple and easy. Now we're just going to divide this by 36. And you're going to get your answer of 150. And since it's 150, it's got to be degrees, right? It's the measure of an arc. And one last problem here for the measure of the arc. They can ask you to find the length of the radius. You're still going to write the same formula. Length equals the measure of the arc over 360 times 2 pi r. The only difference here is you just have other things that you know. So here, once again, they gave you the length. But for the length, you're going to write 105 pi, which Siegel just right there circled in green for you. So that's our length. And then they gave you the central angle, which is 175, which we know is the measure of our arc. So now for length, we plug in 105 pi into our equation. For the measure of the arc, we're going to plug in 175 degrees. That's going to be over 360. And we're going to times that by 2 pi. And remember, if you go back to the question, it's asking you to find the length of the radius. So that radius, r, that's our variable. You can call it r, x, p, whatever you want to call it, but just know that that is what you're looking for. And then from there, you would solve the same way. We can send the page there a little bit. Thanks, Siegel. So here's what we can do. We can cancel those pi's out again. So those are gone. And so now we have 105 equals 175 over 360 times 2 pi, or 2r, sorry. And so now, there's two things you can do here. You can either simplify the 175 over the 360, or you can do what we did before and move the 360 over. Let's do that. So multiply both sides by 360. And what you'll end up getting when you do 360 times 105, you'll get this big number, 37,800. And that's going to be equal to 175 times 2r. And then we just clear up the right side a little bit. 175 times 2 is 350. So rewrite your left side, 350 r. Divide both sides by 350, and you will get a radius of 108. Now, do we need a degree sign for this? No, you don't, because the radius is an actual distance measure. It's not going to be something that you add a degree sign to. So the radius is 108. And those are all the problems that you're going to be seeing. You're going to do great on IXL. Good job.